Okay, so yesterday we reviewed creating box and whiskers, but box and whiskers can also be called box plots, okay? So when we do, we'll take that 5-number summary we get off our calculator after analyzing the data. We'll put a dot for our min value and a dot for our max value. We will put a bar for the median, a bar for Q1, and a bar for Q3. Then the bars turn into our boxes, and the dots get connected. Okay, now the other thing we talked about yesterday when we reviewed box and whisker is we talked about, we call these quartiles because it divides the data up 25% here, 25% here, 25% of the data here, and 25% of the data here. Now, with the box and whiskers, it's easy to identify our Q1 and our Q3. One of our measures of spread of data was called IQR. IQR, to review, is the interquartile range. So these inner quartiles, what is the range of these? So it would be Q3 minus Q1. In our case, it would be 9 minus 6. So this data has an interquartile range of 3. The interquartile range is helpful in describing the spread of the data or the variability of the data if our data contains outliers. Because is the IQR affected by these maxes and mins? No, we don't even look at that. So the interquartile range is a good representation of the spread of the data if our data has outliers, because those outliers would skew the data for the spread. Okay, let's go ahead and take a look at your homework. And please ask questions as we go. So, 13 and 15, we're identifying the mean, the median, and the mode. Mean, median, and mode. Now, 13, the median. When there's an even number of data points, when we have an even data, to find the median, you take the two that are in the middle and average them. That's where the median of 20.5 comes from for number 13. Any questions about 13 or 15? Okay, 17, ask you to create the box and whisker. And then to identify the IQR. Now, the median is also known as Q2. So if you ever see Q2, that's referring to the median. Questions about 17 or 19? Okay, so do you feel confident in your skills to find the average, the median, the mode, the max and the min, Q1, Q2, Q3, Q2 is the same as the median, and creating a box and whisker, also known as box plot? Yes, ma'am.
Okay, so like when you make the actual box thing, like how do you know how to make it?
Okay, so this is the min, this is the max number. So the lowest number is this dot, the highest number is that dot. Okay, this is your Q1, this is your median, and this is your Q3. Now we talked about in the past, you've done them by hand. I'm going to allow you to use your technology, and when you use your technology, it spits out the 5-number summary for you. It gives you each one of these pieces of data. Okay? All right. Now, number 21. We have 2 different types of standard deviation. We have standard deviation for a sample and standard deviation for a population. Now, number 21, you were just given a data set as a set of numbers. So that is the entire population. So for number 21, our standard deviation should be the 18.54. Now, if this data set had represented a sample of data, then that first standard deviation, the 20.25, 20.025, would have been the one you went with. But in this case, you were given all the data, therefore it's the entire population, so the boxed answer is the correct standard deviation for number 21. Yes, ma'am?
How would you know whether or not you were given the entire?
In 21, you were just given a set of numbers, and it was not in context of a word problem. And if I give you a set of data, the only assumption you can make is that's all of it, unless I said, this is a sample. So, now, number 23 is a sample, and we briefly spoke about that yesterday, because number 23 is a word problem. It says in 2004, the Cincinnati Bengals scored, and it gave a list of scores in their first 13 games. Now, it didn't say this was all of the games. So we would approach this as if this was a sample. It said the first 13 games. Now, if it had said in all 13 games, then we would have approached it as if it were the entire population. So for this one, we do use the sample standard deviation. Now, there are two ways of determining outliers, and the one you're familiar with is probably the one you used. It's involving the IQR. So, on your calculator, down below where it gave you the sample standard deviation, it also gave you the 5-number summary. You can find Q1, you can find Q3. Now, IQR is, to determine the IQR, it is Q3 minus Q1. So if we subtract these two, we find that this data has an interquartile range of 10. So to determine outliers, they would lie outside the lower bound and upper bound. To find the lower bound, it's Q1 minus 1.5 times IQR. The lower bound is 1.5. Well, in football, the only way to score less than 1.5 is to score 0. Because the lowest actual score that's not 0 would be 2, right? Safety. So, that is our lower bound. The upper bound is Q3 plus 1.5 IQR. So in this case, it would be 41.5. So anything that lies outside this interval is considered an outlier. If it's outside 1.5 to 41.5, well, yeah, there was a piece of data that lies outside that interval, and it was 58. So 58 is an outlier. And if we eliminate 58, look what happens to the mean. It goes from 22.769 to 19.8. And the standard deviation is hugely affected. It went from 11.96 to 5.83. And just looking at the data, even if let's say you have a sibling that's like 12 and you showed them the data, they would look at it and go, 58 doesn't look like it belongs with the rest of those numbers. So not only did it not look like it, it actually tested outside the interval. So it is an outlier. Now, generally when we have outliers, we eliminate those from our data because they do skew our data. And that's what we have here. All right, so 23 was kind of a big problem. 1, you had to know that this was a sample. 2, you had to discover the outlier. So questions about 23. All right, 25 was the one about the thermostats, and you're in a store and you're trying to figure out which one to purchase. The measurements that you are reading are 73, 75, 76, and 37. Which one doesn't belong? The 37. And that 37 is going to greatly affect your mean. So this question says, which measure of central tendency would you be least likely to use in picking a thermometer? Mean, because that 37 pulls the mean down. You would go with probably mode, possibly median, but this question said which one would you not use, and that would be the mean. All right, questions about 25. it gave you a double box plot, and you were comparing Babe Ruth with Hank Aaron, hometown hero. All right, so they gave us data for Babe Ruth, and then they gave us data for Hank Aaron, and you were just reading and interpreting those box and whisker, aka box plots. Okay, now 33 actually asked us for the IQR, not the range, but I got excited when I was going over it second period and threw in the range too. You didn't have to do the range. All right, now, number 34 asks us which Hank Aaron or Babe Ruth, which one of those was their data had a smaller standard deviation? Well, standard deviation describes the spread of the data. So looking at the boxes, which one had the smaller boxes? Hank Aaron. So he had the smaller standard deviation. All right, any other questions?
Wait, can you explain 34?
Sure. When we look at the two boxes, and I kind of wish I had it opened up on the computer, but I don't. When we're talking about standard deviation, we're talking about the spread of the data. And when you look at this blue box, it is like twice as big as the green box. So the data is spread out further. So because the data is spread out further, it would have a larger standard deviation. So Hank Aaron's, because his data is tighter, he has a smaller box, then he would have the smaller standard deviation.
And then for 31, what were you looking at to determine that it favored the 13-1?
That's just an approximate.
I got 20.
So you could,
I put 20.
did you?
Were you looking at like the whiskey?
You're looking at the max, the difference in the maxes. So Babe Ruth's max looks to be close to 60, and Hank Aaron's max looks to be about 47, 48. And so if you find the difference in those maximum values,
I did the difference in that, but then I did the difference in men's because Babe Ruth's men is before Hank Aaron's men. So I added that 7 to the 13. That's why I got 20.
okay, the question says, which player hit the most home runs in a season? So you're just looking at the maxes, because it's the most home runs in a single season.
Okay.
Now, obviously not the same season, because they didn't play at the same time, but... Okay, questions? Alright, now, what I'd like you to do is to take the notes you picked up. The first 3 questions are involving mean and median and outliers. I want you to answer the first 3 questions. See what you think about the first 3. All right, you're trying the first 3 questions.
What do you mean the first 3 questions?
The ones you can see on the board. Yes.
Your what?
Guys, what are our measures of spread?
No.
Is that your max and your min?
No.
Okay, one of them is your range.
Okay.
Okay? Measures of spread or variation. Okay? So let's review then. What are our measures of spread? And we also call this variation. Okay? So the first one you learned was range. It is the maximum value minus the minimum value. The second one you learned in either 9th or 10th grade was IQR. Describes how the data is spread. IQR is the Q3 minus the Q1, the upper quartile minus the lower quartile. And then the other one that we learned yesterday, standard deviation. All three of these are ways to describe how the spread of the data. Now with standard deviation, we had two. We had sample standard deviation, which was the square root of the sum of each piece of data minus the mean squared over n minus 1. Or we had population standard deviation, which is the square root of the sum of each piece of data minus the mean. And we used mu yesterday for the mean. Squared over n. Now remember, x bar means mean. So those were our measures of spread or variation that we discussed yesterday. Do you need to bring that to me? Because that's the fourth time. Thank you. All right, so which of those measures of spread requires the mean? The standard deviation. Which measures of spread require the median? Well, in effect, the IQR does. Because to determine Q3 and Q1, if we were doing this by hand and not using our technology, what do we find first? The median. Okay? So, it would be the IQR, because in effect, we need the median to find that Q1 and Q3. Okay, so could having an outlier greatly affect your median? Well, the IQR only focuses on that 50% in the middle. It doesn't look at the ends. Where do the outliers live? At the ends. So the IQR is not affected by the outliers. The median is not affected by the outliers. Wait. No. I said not, and then I circled yes. But the mean is. So, when the median is not, then the IQR is not. Is the range affected by your outliers?
Yes.
Yes. Because you use those outliers when finding the range if you have outliers. Now, if the mean is affected, look at standard deviation. What do you see in both of these formulas? Mean. So if the mean is affected, the standard deviation is also affected. That's why you saw on that problem 23, the one about the football scores, when we threw out that outlier of 58, these numbers looked much better. They looked like the rest of the data. That 158 threw them way off. Okay. All right, so yesterday we talked about two things. The center of the data, central tendency, where does the data tend to lie, and the spread of the data, the variation. So with measures of central tendency, it was mean, median, mode, right? Measures of spread, range, IQR, standard deviation. So we have 3 for each. Now, and we also talked about identifying outliers. So one method that you already knew walking in the store was the first one. We can identify outliers. Those are any pieces of data that fall outside of Q1 minus 1.5 IQR and Q1 plus 1.5 IQR. If it does not fall in that interval, it is considered an outlier. Another way of determining outliers involves standard deviation. So we actually have two methods of determining outliers. I'm totally fine with you using the IQR. But the other method is with standard deviation. It's the same idea. It's any piece of data that falls outside of 3 standard deviations from the mean. So this would involve the mean. Now, and plus or minus 3 standard deviations. Okay, so those are our measures of center, mean, median, mode, spread, range, IQR, and standard deviation. Outliers, these are our methods of finding it. Today, we're going to add another way to describe our data distributions, and that is with the shape of the data. The shape of the data. So we have some common shapes that I'm going to want you to be able to describe if I give you a data set. The first one, symmetric, unimodal, bell-shaped. All right, what does the prefix uni mean? One. And what do you think modal is talking about? Mode. So, with a bell-shaped curve, with a symmetric, and I did my best to draw symmetric, I'm not good at it. A symmetric, unimodal, bell-shaped curve, it looks like this, where there is one mode. And when we get to the normal curve, the mean, median, and mode are all the same. All right. Now, the next one is considered skewed right, where the tail of the data is to the right. So it's going to have the hump up here, and then the tail of the data goes to the right. So skewed right, the tail of the data is to the right. Okay, so if we did like you guys studied in 9th grade and did a dot plot, okay? So let's throw some values out. Let's say this is 10, this is 15, this is 20, so that would be 25, this would be 30, that would be 35, this would be 40, that would be 45, this would be 50, and you had some data. And you made your little dot plot. Sometimes we did dot plots with X's, sometimes we did them with dots. Do y'all remember creating dot plots? Okay. So we might have a dot plot that looks something like this, and then it starts to come down, and then it comes down, and then it comes down, and then we have a little bit of data hanging out over here. So if we thought about this as a curve, if we superimposed a curve over this data, do you see how the tail of the data is to the right? Okay. And so if we describe the shape of this data, we would say this distribution of data is skewed right. Where do you think the tail is going to lie when it's skewed left? The other way, to the left. So the tail of the data is going to go to the left, so it would look like that. All right, uniform. All the same. All the data looks the same. Same. All the data looks the same. So if we did it like a histogram, if we describe the data using a histogram, let's create a histogram real quick. It might look like this. You would have most of your data would be right about the same. Well, I'm trying to draw straight, but I can't. So all the data kind of looks the same, about the same all the way across. We would actually call this fairly, maybe even mostly, uniform. Okay? Symmetric, think about what that means, and bimodal. What do you think bimodal means? 2 peaks. So they're going to look very similar, but we're going to have 2 of them. Symmetric and bimodal. Now the last one is non-symmetric, yet bimodal. So non-symmetric, we might have 1 There we go. Okay, so we've talked about how to describe the center. We talked about how to describe the spread. We talked about how to determine outliers. Now this is how we would describe the shape of the distribution. So, our mnemonic to help us remember everything when we're describing a distribution is SOX. Shape, outliers, center, spread. Shape, outlier, center, spread. You got to address all four things. Shape, outlier, center, spread. Okay, now, do you see this is this is done on the computer, so it's beautiful. When we have a symmetric distribution, that mean and the median are the same. But when our data is skewed right, when the tail of the data is to the right, that mean gets pulled to the right. Do you see how the mean is to the right of the median? When we have maybe even outliers up here at the upper end, it pulls that mean up higher. It makes the mean greater than the median. So when the mean is to the right of the median, it is right skewed. But when our tail of the data is to the left, look where the mean is. It's to the left of the median. Okay? So if I didn't give you the graph, but I just gave you the mean and the median, if they're the same, it might represent a symmetric distribution. But if the mean is greater than the median, it would represent a distribution that is skewed right. And if the mean is less than the median, it would represent a distribution that is skewed left. Okay. Now, this last little paragraph kind of summarizes some of the things that we need to look for. When our data is skewed or it has outliers, what do we use so that the outliers don't affect?
Box and whiskers.
Okay, we can look at the box and whiskers and we ignore those whisker parts and we just look at the box. So we're going to go with that median, which is in the box and whiskers, and the IQR. Because the median and IQR are not affected as much by outliers. But if we had a fairly symmetric distribution without outliers, then every time we should use the mean and what type of description of the spread of the data? Standard deviation. Okay, so on the back is an example of a data set. I want you to take your calculators and I want you to enter that data and I want you to find the 5-number summary and leave it in there because I'm also going to show you how to do a box and whisker by hand and with technology.
Can you enter all that information?
Yes, please. It's 40 pieces of data. Okay. Alright, so those of you that were not here yesterday, when you open up your calculator, you hit Stat. And then the first thing we have to do is enter our data. So you hit Edit. And you enter your data in L1. So Stat, Edit, enter your data.
Oh, well, we once.
Go. Go. Do it.
I know I am. I'm
Yeah,
gonna
but this is like,
what was this one? It's mean and standard deviation.
I'm so good at this now.
Is it mean plus standard deviation?
Yeah, it's mean and.
And. Okay. So when you get all your data in, then what you hit is stat, arrow over to calculate, and we're performing one variable statistic, so you hit enter. It should say L1. If it doesn't, you hit second and 1 for L1. And then enter, enter, enter.
How do I clear again? Isn't it like stat 5 or something? Stat.
To clear old data, you go up over the heading and hit clear and enter. And your old data goes away.
Stat 5 is when you accidentally delete a column and you're trying to get a column to come back.
Thanks.
Okay.
Okay, so this gives us the mean. It also gives us a sample standard deviation and a population standard deviation. And then if we arrow down, we see the 5-number summary. The min, the Q1, the median, the Q3, and the max. And that's the data we need to create a box plot.
I really kind of different a little bit. Like decimals.
Then what may have happened was you may have entered one number in wrong. So, the min is this dot. The max is this dot. The Q1 is this bar. The Q3 is this bar. Now, sometimes the median could also be called Q2. So if you ever see Q2, that means median. But the median goes here. Now, looking at this data, do you see that it is pulled to the left?
Yes.
Yes. The data, one way we can describe the shape of the data is we would say it is skewed left. Do you see it in the box plot, skewed left? Now, this is a dot plot of the same data set. Do you see if I superimpose a curve over this, that the data looks like it's skewed left? Okay, so you guys did dot plots in 9th grade. That's just where you take each piece of data and put a dot for it. So you can see the skewness in the box plot. You can see the skewness in the dot plot. You can also see the skewness in the histogram. This same data right below it is graphed as a histogram. Do you see that it's skewed left? If we superimpose a curve over it, you can tell the tail of the data is to the left. Now, stem and leaf, you probably haven't done since middle school, but if you take your stem and leaf and you rotate it like this, do you see that it is also skewed left?
The tail.
That's a stem.
The stem and leaf would have like the tens place. And then the ones place. Actually, this is representing a different data. No, it's not.
No, it's the same.
32, yeah.
37, 30.
And they have it divided up just the way we divided it there. Yep. Yep. Okay, so tonight's practice has to do with socks. You're going to practice identifying shape, identifying outliers, talking about the center, and the spread of data. So when we deal with data distributions, those are the 4 ways we would describe our data distributions: with shape, outliers, center, and spread. Shape, outliers, center, and spread. Socks. Okay.